So this is flexibility in Python. Like there are few naming conventions, there are few nomenclatures or rules wherein for basic fundamentals you need to understand. Once you get a grip of writing these fundamentals, now there's no easiest language on earth than Python to write on. Like the way we talk, you can write your code in the same way. So rules for Python's variables is like constants and variables can have a combination of letters, like in lowercase from small a to z, uppercase a to z, and numbers from 0 to 9. You can create a variable with a sensible name. That means do not use any predefined or system defined identifiers to your variable names. Again, here in Python variables are case sensitive, and avoid using system defined keywords. Now in constant, most of the time we write it as const. Now here there again is not necessary to define that. The way I'm going to define my variable will be a constant. So you treat it in entire program as a constant value. What you need to do is, like most of the time you write it as like this, as 3.14. So this indicates that pi as pi variable name will be treated as constant in entire program. Now in Python there is no need to write like this. You can directly write in capital forms as 3.14. Pi will be treated as constant in floating numbers. If you want to go for like gravity equal to 9.8, or you want to fetch another result, let's put a Boolean value. You can see, observe there, the moment I use system keywords, the color changes. Right, it came to green. Right, so like there's also a variable named as none. So you do not have to define any data type. So I'll take a simple value and store that data type as none. You can see the color has changed. So it is a system defined keyword. So now if I try to execute it, print value, it will give as none. Now there are literals. I'll give you an examples of literals, like its type and its example. So it will be easy for you to understand. So if it is decimal, we may have numbers like 5, 10, maybe our negative numbers as -90. If it is in binary form, it also accepts, like you may have 101 as binary, 0b, you can have any like 3-bit, 4-bit, 5-bit numbers to represent in binary form. You can also have it in octal form. This is octal. You can have it in hexadecimal form. Just get to know that, like most of the times in like depends on your algorithm or your project what you're going to use. If it is at that level, you need to have knowledge of this. You know about this floating point, like 10.5, or you may have like 3.14. We also support Python here in complex. It is a keyword 7 plus like 8j. So imaginary numbers and integers are here collaborated. Now there's a collection of like literal collections. We have a special data structures here in Python. We have list, tuple, sets, and dictionaries. This is the heart of Python. And like what we are seeing now is basic fundamentals, wherein we do not define any kind of data types. It is not necessary, because automatically, depending on what numbers we are taking, processing input and output, it will be taken as for processing. But the defined data structures, that is list, tuples, sets, and dictionaries, these are very much important. There are lots many functions. The more you practice, the more you will get to know about these functions and methods, because this will really help you at a next level of programming in Python. Those are not basic, those are very advanced ones, and that is why everyone is feeling so like easy to execute Python programmings. Python features, if I like, I would like to mention like it supports structured programming methods as object-oriented programming. Object-oriented programming, like same is it is of Java. Like we we have classes. Everything is wrapped within a single entity named as class. Every static variables, instance variable, everything is within the class. So that's why it is called as object-oriented programming language. It is mostly used to build large applications and also provides a high level dynamic data types as we have seen here, and also supports dynamic type checking. So what kind of data type I'm using, I do not have to explicitly mention it unless and until I use it from the user, right? And there's automatic garbage collection also, same as of Java, but more optimized way. As like I said, if I use a variable here as this pi, I've calculated it twice, thrice, and later on I'm not used it at any instance. So why should such variable or object consume memory into my application? So what does compiler decides after a very long time if it is being not used, or in case your virtual memory is getting low, in that case automatically it unreferenced it. It does not delete it, right? It does it inactive. For example, you might have seen in nowadays in Chrome browser, if you open multiple tabs and few tabs are not used for a very long time, it suggests you that these tabs are inactive or being unused for a very long time. So instead of consuming memory, could it be like kept inactive? The moment you click on that tab and refresh it, it will be again back into the memory. Like same way here, if these variables are being not used for very long time, it can be dereferenced, right? So it will not be linked, actively linked. The moment you want to recall it, it will be available in the memory, you can again call it. But for a very long time, if it is not letting other objects to consume memory, at that instance again automatically done by the compiler, that part of dereferencing any objects to release your memory is called as garbage collection. The major advantage of Python is that you can integrate it with other languages also, C, C++, Java, .NET. So it is platform independent as well as language independent. So your programming languages can run on any other program. It's very easy to learn. The code is very easy to maintain. It has a very broad standard library. There are many contributors in Python library. It has an interactive mode. We have graphical user interfaces also in Python by using tkinter package. It is very portable. You can have a wide variety of hardware platforms on all of Windows operating system, Linux operating system, any flavor of operating system you can run Python. It also provides a very like good and major commercial support for databases. And if you talk about databases, it is scalable. It provides a better structure and support for large programs than shell scripting. I'm explicitly mentioning it. It provides a great support for programs, for large programs than shell scripting. That's why I said that databases are very helpful here, and it has a very broad library. For databases, you can use MongoDB, MySQL, Postgre, SQLite. So irrespective of any platform, it is very easy for you to see how it implements. Talking about interpreter, I mentioned that it is an interpreter, whereas in C, C++, Java, if you talk about, you have a .java file. Yeah, like I'll compare it with you an object-oriented language only. So initially, the moment you write your code, it is in .java file. The moment you compile it, you get an object file, .obj file, and then you get an executable file, right? This is the scenario here. So what does Python interpreter is? You have a source code program as in .py. Then there's a translator to a virtual machine of Python. In between there's bytecode. So this translation of your code into a virtual machine language, intermediate code, this is nothing but your Python interpreter. And whatever program you have written in .py file will be executed and shown directly on the screen. So this is like that interactive mode helps you to execute more faster. Right. Each command you enter in front of Python prompt here is read then translated, and then executed in a single instance. Now, this is a very good view of Python Jupyter. Mostly in the very first versions, what we were doing is we were using Python idle. That was an shell editor of Python. But nowadays, nobody uses it because drag and drop facilities and more interactive IDs are available for Python. Apart from Jupyter, if you want to use any other ID, I would recommend use Spider. And in online sessions, I would recommend Google Collaboratory. These